Hi Year 11. This is the first in a series of 4 videos for the topic Further Functions for Extension 1 Mathematics. Here's the outline for the topic. In this first lesson we're going to look at inverse functions, then we'll look at graphs of inverse functions, then domain and range including restricting the domain, and then we'll finish off with parametric form. So an inverse function is one that undoes a function, and this is how it's denoted. F to the power of -1 and then in brackets x. So it's like this. If we have a function that is changing apples into lemons, then the inverse function will take the output of the function and turn it back into the input. Here's another example. So here's the function f. It turns a into 3, b into 1, and c into 2. The inverse will take the 1, 2, and 3 and then turn them back into their original form. Now we've actually already seen inverse trig functions in years 9 and 10 when we wanted to solve something like tan beta is equal to 0.4. We want to solve for beta. We want to get rid of this tan. To take it over to the other side, it becomes its inverse. So beta is equal to inverse tan of 0.4. And on the calculator, it's sitting above the tan button. And the answer here is 22 degrees. Let's start with inverse relations. We form the inverse relation by interchanging x and y and then making y the subject. So suppose we've got y is equal to 3x. Interchanging x and y will give us x is equal to 3y, and then making y the subject will give us y is equal to x on 3. So this is the inverse relation of this. Now, if the new relation is a function, then we call it the inverse function and we use this notation. Now, this question we just did, it is a function. Y equals x over 3 is a straight line. So the inverse function of f of x equals 3x is f to the -1 of x is equal to x over 3. Now, because we switched x and y when we formed our inverse function, the x and y coordinates of any point in the original function will be swapped in the inverse function. So here's our question we were doing. F of x is equal to 3x and f to the power of -1 of x is equal to x on 3. So the point 1, 3 lies on this line. Okay, just check that out. Put the 1 in there, you get 3. So guess what point lies on this one? 3, 1. Okay, let's put 3 in there. 3 divided by 3 is 1. You see how they switched? Let's look at a couple of examples. Find the inverse of f of x is equal to x squared and decide if it is a function. Now here's a tip. If there's an f of x instead of a y, just make it a y. It will make life easier for you. Now switch your x and y. Now make y the subject. Y squared equals x. Square root both sides. Y is equal to plus or minus root x. Now this is not a function because for many inputs there are going to be 2 outputs. So for example, if we put in x is equal to 4, we get plus or minus 2 as the answer. And in fact, when we graph it, it is going to fail the vertical line test. So it is not a function. Here's example 2. Find the inverse relation of y equals x squared minus 2x plus 3. Switching the x's and y's. Now I want to make y the subject. Now here's the thing. If you've got a y squared term and a term in y, the only thing you can do is complete the square. So here I've got y squared minus 2y. The term in y, the coefficient is -2. Halve it, square it is 1. So I'm going to borrow a 1 from here. Hopefully that makes sense to you. Complete the square and take the 2 over the other side. Now switch it around. Square root both sides, don't forget your plus minus, and then finally take the 1 over. So the inverse relation is y is equal to 1 plus or minus the square root of x minus 2. And when we graph it, we get this. And example 3, find the inverse function of y is equal to 2x minus 2 all over x minus 2. Start by switching the x and y. Now take this y minus 2 up and over to be with this x. Expand the left-hand side. Now we want to get all of the terms in y together. So I'm going to take this 2y over here, and at the same time I'll take this negative 2x over this side. Factorize the left-hand side. Divide both sides by x minus 2, and the inverse function is y is equal to 2x minus 2 all over x minus 2. Now what do you notice? They're exactly the same. And these are called self-inverse functions. So when you have a function and you do the inverse and you get the same thing, it's called a self-inverse function, and they're symmetrical about the line y equals x. Now, a simple way to tell if two functions are inverses is just to substitute in a general constant like a. We're going to substitute the a in here, and whatever we get out, we'll substitute into the inverse, and then if we end up back with what we started, then the functions are inverses. Right, so f of a is equal to 3a. Now substitute that into the inverse. So f to the power of negative 1 of 3a is equal to 3a over 3, which is a. So because we started with a and we ended up with a, then f of x and f to the power of negative 1 of x are inverse functions. So here's an important point. A function and its inverse undo one another. So we could have f to the negative 1 of f of x will equal f of f to the negative 1 of x will equal x. So this is another way to prove that two functions are inverses. Show algebraically that f of x equals 2x plus 1 and f to the negative 1 of x equals x minus 1 all over 2 are inverse functions. So we're going to start with f to the negative 1 of f of x. So instead of f of x, I'm putting 2x plus 1 in here. Now when I work this out, anywhere I see an x, which is here, I'm going to put 2x plus 1. So 2x plus 1 take away 1 all over 2. Tidy up the top, I get 2x over 2, which is x. So because this is equal to x, then f of x and f to the negative 1 of x are inverse functions. We can also go the other way and start with f of f to the negative 1 of x. Instead of f to the negative 1 of x, I'm putting x minus 1 over 2. And everywhere in this function that I see an x, I'm going to put this. Tidying this up, this will cancel out. I end up with x minus 1 plus 1, which of course is x. So again, they are inverse functions. Okay, that's it for this lesson. In our next lesson, we're going to look at graphs.